Hey everyone! Have you ever tried to learn how to code but got stuck? In my new Python programming class, we're going to break that loop. This course is primarily focused on people who are complete beginners, so don't worry if you don't have any background. This course is different than other courses because we're going to teach you to think like a programmer and solve problems like a robot. So let's get started. Hi everyone! So in the last video, we talked about incrementing and how we're able to increment to make our final string value here, which is this final encrypted string. We can look at this again. Let's take a look at what this actually looks like. If we remember, encrypting was a way of kind of jumbling up our text so that it looks like gibberish to most people, but that there's an actual method to create it so that someone else can basically take this in and figure out what the original message was. So that's the idea behind encryption, and we were able to do it. Now I want to jump back a little bit and talk a little bit about our encrypt letter function. I'm going to paste it down again here. And if you remember, this encrypt letter function took in a particular letter, let's say B, and it would encrypt it for us, which means translate into this new language. Now, we were able to solve this with these if-then statements, but there's actually an easier way to solve this in Python, and that's using dictionaries. Dictionaries are very useful tools in Python. And to take a step into this, the idea in general is that we are associating two different types of values with a dictionary. There are keys and there are values. Now, why would we want to do this? So first of all, it cleans up a lot of our logic. So this is very long-winded for us to write this in this way, right? We had to say A goes to X, B goes to Y, C goes to Z, so on and so forth. And there's probably better ways of handling this. So that's one thing. The second thing is that this isn't very flexible at all, right? So here we have to use an if statement, and it's going to check every single one of these values until it finds the correct value. So this isn't very efficient. It takes a very long time. There's actually easier ways for computers to look things up, right? We're doing this ourselves. So there's a couple of things here that are important. The first thing that I want to talk about is generalizing this a little bit. So here we have A goes to X, B goes to Y, and we talked about how that deals with a shift, right? So the reason that A goes to X in this case is because we're shifting to the left by 3, and it loops around. So A is going to go back here to Z, Y, X. B is going to go to A, Z, Y. C is going to go to B, A, Z. D is going to go to C, B, A, and so on. That's a shift of 3. But what if we wanted to use a different cipher? Then we'd have to, first off, figure out what all the letters are supposed to be, and then change them here. So if I wanted to do a left shift 5 cipher, which would be A goes to Z, Y, X, W, V, B goes to A, Z, Y, X, W, and so on, it would be a pain in the butt, right? Because I'd have to figure out a way to just change all these letters. So instead of X, I would say V, and so on and so forth. I don't want to do that. What I'm going to do is, instead of associating every letter with a cipher, with a letter in the cipher, I'm going to first associate letters to numbers, and then I can perform some arithmetic on those numbers and translate it back into a letter. So if that makes sense, I want to find a way to translate letters to numbers, perform some operation, and then go back from numbers to letters. So first off, I think the general idea here is, why would I want to do that? I just mentioned that it makes it more generalized, and once you turn it into numbers, there's actually a way of manipulating numbers that does exactly what we just described for any number of shift, and that's using modulo. Now, we actually saw a little bit of this here, this mod 26, right? X plus n mod 26. And it actually describes this exactly here. A goes to 0, B goes to 1, Z goes to 25. So first off, we already seen a little bit of this, and this is the general idea, but because once we translate numbers, we can easily add or subtract the numbers, right? We can change it from 5 to 7 or 7 to 9. And as long as we have some formula to figure it out, we're good to go. But letters are harder to deal with. There's no clear association between the letters, right? So that's one reason. The second reason is we can actually make this a lot more interesting and maybe a lot more harder to read than just using shifts, right? Instead of using a shift, we could have some algebraic formula that kind of pops out some number and then translate it back into a letter. And as long as you know that algebraic formula, you now are able to solve it. So we can make more complicated and more intricate ciphers using this method than just going between one letter to another. So that's the general idea here. And this is what we're going to be doing in the next few videos. And the way that we're going to do this is using dictionaries, as I mentioned before. Hopefully this makes sense. And the next video, we're going to talk about dictionaries and how we can use dictionaries for great good to be able to translate these letters into numbers in a very straightforward way. Okay, thanks.